Okay, we're going to continue on with the discussion of several different prisms here. I think I left off where I was encouraging you to organize your work. We're going to calculate the base surface area, lateral surface area, and then total surface area with volume. On this one, I was pointing out that we have, a triangular based prism here. Our top and our bottom are triangles, so we're going to have to switch gears and start thinking about the area of a triangle, and that's two-dimensional triangle. The formula for that is 0.5 times base times height. When we plug in the 5 and the 12, we come up with an area of 30 centimeters squared. But there's two of them. There's the top and the bottom, so when we're finding the base area of two bases, we're going to have to double that to come up with 60 centimeters squared. Okay, moving on to our lateral surface area. This is somewhat different than when we had our prism, where we had something that looked like this, where we had pairs of parallel sides. We don't have that with this. As far as our lateral faces, our rectangular faces, we have one of each. So I labeled these, the left one, the right one, they're both on the back side, and then the front one. Okay, so they all have a height of 14. So I circled that height, the three-dimensional height I've circled here. So you can see that you're going to take each of these edges, 12 times 14, 5 times 14, and 13 by 14 in order to get the area of the left, right, and front rectangles. So when I calculate each of those, then I can add that up to get my lateral surface area of 420 centimeters squared. My total surface area is the sum of the base surface areas and the lateral surface areas. So when I add those up, I come up with 480 units squared. Okay, moving on to the volume. Again, I'm going to be using that formula where I have capital B times capital H. And when you see that capital B and that capital H, we're talking about the three-dimensional base area times the three-dimensional height. We have to have our head in the game and recognize that this base area, it's a triangle. So we're going to be using the formula for a triangle. So this portion of what I've plugged in here was actually this formula over here, 0.5 times base times height of that triangle. Then multiplied by the three-dimensional height. It's kind of like you're finding the area of a triangle and stacking it 14 times is what it amounts to. So we came up with a volume of 420 centimeters cubed. Okay, moving on. We're going to go on to the next one, and this one is very similar in that you're dealing with a right triangular prism, but this time it's sitting on one of its sides. The front and the back are bases, and so you kind of have to recognize these things turn around in three-dimensional space. So I went ahead and we're working on finding the area of that triangular base again. Remember that it's going to be a right angle right here. We recognize that we're going to use our base and our height. Two-dimensional base and height have to be at right angles to each other. So we plug that in, 0.5 times base times height. We end up with 6 units squared. We know that we've got the front and the back. We have two of those triangular bases, and so when we double that, we come up with 12 units squared. Okay, so again, moving on to finding our lateral surface area, we have to kind of recognize that we have our upright here on the left side, we have our lower bottom, and then we have this diagonal piece here. And so we're going to have to find the rectangular area of each of those areas, each of those rectangles. But when I'm looking at this, I recognize I don't have one of my edges here. So we're going to have to plug in our Pythagorean theorem from past lessons. Remember that was the leg squared plus leg squared equals our hypotenuse squared. So we're looking at this triangle here. We're trying to find the hypotenuse of this triangle. So we're going to use 4 squared plus 3 squared gives us our unknown squared. That's what I was plugging in here, and I've set it up very algebraically. So I'm going to work step by step. Come up with 25 is equal to x squared. I rewrote it because I want you to see that we're going to square root each side because that square and that square root go away. Square root of 25 is 5. So we went through all of that to find that this edge is 5. Here and here we have 5. Okay, so now we're ready to roll. We can go ahead and calculate our rectangles. Now keep in mind what I did is I circled our three-dimensional height. The height is going from front to back. The height is going to connect the two bases. That's true in all of these cases. The height will connect the two bases. So 2 is our height. So one edge, 4 times 2 gives us this back, I don't know if you'd call it, I'd say the back left panel. And then 5 times 2 is going to give us the diagonal. And then the bottom horizontal rectangle is 3 by 2. So we add all of those up. We've got our lateral surface area of 24 units squared. Our total surface area is going to be the sum of both of those. When I add all of those, both of those, we end up with 36 units squared for our total surface area. The volume, again, we've got it. I've written it's base area times height. Those are capital, meaning it's 3-dimensional base times height. We have to remember that this is a triangle at the front of this figure right here. So we're going to use that formula right there. And we also used it over here. This time we're multiplying by the height, which happens to be 2. So it looks like that's kind of unusual that they come out to be the same. It's just that height was 2. If that height would have been something different, it would have been something different. Okay, so our last one is really a definite challenge. We're going to be looking at this piece here, and what I want you to recognize is that this is a trapezoidal prism. It's also sitting on one of its lateral faces. The front and the back are the trapezoid here. So we have 2 sides that are parallel to each other. Actually, one of the edges is at right angles. So looking at that 2-dimensional trapezoid, it's actually the height there. So we're going to be using the formula for the area of a trapezoid, which was 0.5 times the height times the sum of the bases. So again, if I kind of cover up all the rest of this, you can see that's the trapezoid we're going to be dealing with. And so this was, if it's 3 there, it's 3 here. If it's 10 there, it's 10 here. It's just that it gets a little cluttered when we start labeling every single thing. So we're going to be finding the area of that trapezoid, which is the 0.5 times the height of 3, which is at right angles to both of the bases of that trapezoid, times the sum of the bases. We come up with 22.5 units squared. We recognize that we have 2 of these trapezoids. We have the front and the back one. So we have a total, our base areas, our 2 bases, total out at 51 units squared. So finding our lateral surface area, we're going to have 4 different panels that we need to find. We have the top, which is going to be 10 by 4. We have the bottom, which is going to be 4 by 7. We have the right, which is going to be 4 by 4.25. And then we have the left one that is going to be 3 by 4. 3 here by 4. So we add all that up. We've got 97 units squared. Our total surface area is the sum of the base areas plus the lateral surface area. Plug that in. We had a total surface area of 148 units squared. Our volume, again, that's 3-dimensional volume, that trapezoid. This part comes from the formula for trapezoid, so we use that here and here. But this time we're multiplying by the 3-dimensional height, which, again, the height, 3-dimensional height connects the 2 bases. And that comes out to have a volume of 102 units cubed.